So hello and welcome to Steps to Maths, and in this short video we're going to be looking at solving indice equations or index equations or equations involving powers. So let's look at a basic one. Let's have a look at 2 to the power of x equals 4. Now immediately in our head we'll recognize that 2 squared is equal to 4, so we'll know that x is 2. But we're going to look at the method for how to solve this, and the method that we're going to be using is writing both sides as a power of the same base. So we write 2 to the power of x on the left hand side, and we want to write 4 as a power of 2. So we know that 4 is 2 squared, and we write down 2 squared. So that's the first thing that we do. Instead of just writing down the answer, we're going to write 2 to the power of x equals 2 squared. Then we compare the left hand side and the right hand side, and when we compare them we know that if this is equal to this, then x must be equal to 2. This might sound a little bit long-winded, but I think you'll find it becomes more useful when you're looking at more difficult questions. Let's look at another question. 3 to the power of x equals 27. So we want to write 27 as a power of 3. We go through our powers of 3. 3 to the 1 equals 3, 3 squared equals 9, 3 cubed is equal to 27. Now we need to know and immediately recognize powers of 3. So we know 27 is 3 cubed. So let's rewrite this equation so that we have both sides to the same power. 3 to the power of x equals 3 to the power of 3. Compare the left and the right, and we see that x must be equal to 3. And that is the answer to our question. So the reason that we're looking at that, let's have a look at a different type of question. 9 to the power of x is equal to 3 to the power of 4. So we can see again that we're going to be using powers of 3 because we recognize that 9 is 3 squared. So we want to write everything as the power of the same base. So we're going to replace 9 with 3 squared in brackets. Remember, when we're substituting, we always replace what we're substituting in brackets. So we've replaced the 9 with 3 squared. It was 9 to the power of x, so it's going to be 3 squared in brackets to the power of x. So see this whole thing? That's where the 9 used to be. Equals 3 to the power of 4. Then we use our rules of indices. We know that 3 squared to the power of x is 3 to the power of 2x. You multiply the 2 to the x and we get 3 to the power of 4. Then we compare our left hand side and our right hand side. We see that they have the same base, so the powers must be the same. So 2 to the x must be equal to 4. Just compare the left and the right. This and this must be the same so that the whole thing can be the same. That just makes sense. Just to clarify that again, imagine I wrote down 3 to the power of something equals 3 to the power of something. We would know that this and this would have to be the same. So just apply that thinking to this. This and this have to be the same. 2x equals 4, x equals 4 divided by 2, which is 2. Let's look at another question. 3 to the power of 3x is equal to 27 squared. Immediately we recognize that 27 is 3 cubed, so we're going to replace 27 with 3 cubed in brackets. So we get 3 to the power of 3x equals 3 cubed in brackets squared. We apply our rule. A power to a power, you multiply the powers, you get 3 to the power 6. Compare the left and the right. We've got everything written as a power of a single base, so we know that 3x must be equal to 6. And x must therefore be equal to 2. Okay, the last thing you would do is you get your calculator and you would check your answer back in here. X to the 6 equals 27 squared. You'd put both of those into your calculator and check that they both gave you the same answer. Okay, so that's basically what we're going to be looking at there in these questions for the moment. In future questions, we're going to be looking at square roots, but that's fractional indices. So that's something we'll look at in the future. But for the moment, have a look at solving these equations by writing everything as a power of the same base. So if you see a powers of 3 and powers of 9, we know that it's going to be everything as a power of 3. You need to recognize powers of various numbers. You need to recognize that 4, let's just write these out on a separate sheet. You need to recognize powers of 2. 2 to the 1 is 2. 2 squared is 4. Then 8. 16. And 32. You need to recognize powers of 4. You need to recognize powers of 8. You need to recognize that 8 squared is also the same as 4 cubed. So if you're replacing 64, it depends what base you want. If you want a base of 4, replace it with 4 cubed. If you want a base of 8, replace it with 8 squared. And you should, of course, recognize all of your squares. You should recognize these numbers. 25, that's 5 squared. 36, 49, 81. You should recognize all of these numbers. So these are the important ones here. These are quite important as well. Using powers of 3, that's going to be important as well. And very occasionally 3 to the power of 5. What's that equal to? 243, I guess. Okay, so recognize your powers, recognize your squares. You have to know your timetables. You have to know all of these things. And the idea in all of these questions is that we write everything as a power of the same base to solve an equation. So we have a base to some power, and when we have a base to power is equal to the same base to some power, these must be equal and we can solve our equation. Okay, remember as well, it has to be a single base here and a single base here. As soon as we have pluses and minuses, and we're into a lot of difficulty and they're very hard to solve, but we won't be looking at them. Okay, so remember that we're replacing values so that we have the left hand side and the right hand side written as a power of the same base, and then we can compare the powers and we can get the answer to our question. Okay, so that's that.